Hello, everyone. Today is April 28th, 2021. I'm here with Naveen Kashyap. Naveen is a software engineer for Instabase. He is a graduate of UCSD with a master's in machine learning. It's machine learning, correct, Naveen?
Yeah, well, master's in computer science. My specialization was artificial intelligence, machine learning.
Awesome. Thank you for coming on the podcast, Naveen.
Of course, thank you for having me.
So, you've been writing up software for a long time now, haven't you?
Yeah, I would say I started in late high school. Actually, it goes back to a friend of mine was like, "Hey, want to build a game with me?" And at the time, I wasn't really interested in computers. I had never really been introduced to it, and we built a game, and that was the summer after my junior year of high school. And after that, I kind of just fell in love with it and did it throughout undergrad and then grad school, and now as a profession.
Nice.
Yeah.
How have you seen your, engineering practice evolve over those years?
That's a good question. I would say I became more aware of how larger systems kind of come into play, as well as how software really interacts with the hardware of the computer or the machine it's running on. And I say that from a purely like electrical engineering sense. So I did electrical engineering as an undergrad, and I did somewhat of a mixed discipline with computer science during that time in undergrad as well. And so I got like a really, I think, unique view or like interesting view of kind of how the hardware and all the way down to like the chemistry of a circuit board, kind of meets a computer chip, and how languages are then processed by the chip, and the individual processes on the chip, all the way up to like how do you abstractly think about what a computer can even do. And so I kind of got it from both sides and was able to see how the software meets the hardware. And so I think that's given me like a good sense of what the computer is actually doing under the hood, and how some of these things work, and why certain chips are better for certain things than others.
Nice. That's a deeply complex process, and a computer, has, like you said, has a lot of systems within that system, and it's not easy to
Right.
wrap your head around.
No, it's not, because despite the physical size of your device, there's an extraordinarily large amount of things happening in a computer at any given time, and it's hard to really understand how exactly large and complex and vast these systems can be. Just because physically it's small, we don't really perceive it to be this like largely complex thing that we're walking around with in our pockets, or that we're carrying with us as we do our work in a Starbucks.
Yes. So when you say how, it links with other systems and how it's interconnected within a larger system, do you primarily mean other hardware systems, or would you even mean just also within a software sense too?
um I I think you can think of it as both of those situations where it is with other hardware. In some sense or another, hardware only really interacts with other hardware through software. And so really it becomes, well, how does this software interface with that software? And that software can be across the internet, it can be next to your computer, it can be over Bluetooth. That the other system over there might, it could be a number of different things. But I think largely from my perspective, the way that I've seen my understandings grow are going to be more like in a software sense, which aligns very closely with how do you design in a very logical, repeatable, scalable fashion? How do you design a system that can, handle the weight and pressure of being on the internet, and kind of handling the struggles that come along with that.
Have you seen software that is, have you been a part of teams that have produced weak software that isn't scalable and isn't really dependable?
Um, I would say not in my professional life. I haven't. I would say there's an extraordinary amount of work that goes into making sure that that just doesn't happen. And if it does happen, you realize it fairly quickly. And there's typically a reorg. I've been a part of companies where I joined as an intern right as they're starting to make the change from a not great software system or design to a much better but far more complex system as it is. But then naturally in school, during my research time, the things I built were for sure not like very strong in terms of scalability or production ready. I mean, things rarely are. The act of becoming production ready is a fairly complex act, and requires like intentional dedication to making it production ready. So no, I haven't really been a part of a team that's just like failed at that metric. But it's easy to see how one can make that mistake.
How do you, how does a team that, you've been on, or teams generally find these issues quickly to make sure that they don't, comp or, you know,
Run into them.
run into them and then become bigger problems down the road?
Oh yeah, I see, I see. So they don't kind of build up on each other.
Exactly.
That's a good point. So mainly by hiring the right people, is the first way to do it is you need to hire someone who's done it before or who's studied it before, especially for these large systems. And so, but it will become apparent when your system is not, can't handle the volume or the expectations that are kind of expected of it. And it usually comes in the form of like high latency. So the system ends up becoming very slow. It's not very reliable. So there's a lot of system downtime. You'll, try to log into whatever system and it'll just be like, it's as if someone pulled the plug on it. You'll start to notice these issues, and it has largely to do with the fact that the systems that are trying to talk to each other are bottlenecked somewhere, or that the hardware between them can't keep up with the amounts of data being passed between that point. And so in order to make sure that that doesn't happen, you can do things like load testing, right? And load testing is just the most simple way of you generate traffic, you generate data, large amounts of data, and you just throw it at your system. You say, go and compute all of this data. And the expected result is that you can see, you start off small, you throw a little bit of data at it, and then you start growing larger and larger and larger. And the idea is you're looking at the latencies, the number of errors, and the amount of downtime that you have as it takes on more and more data. And the idea is you should not really see an exponential growth in those problems. It should be like, if it's, well, really, and ideally, if you're able to scale well, if you don't have these issues, you're not going to see much more latency if you're throwing a bunch of information at something versus a small amount of information. And so just proper testing to make sure that your systems are good and can kind of withstand the pressures of being out in the wild.
What's the definition of latency?
Latency. So you can think of it in the sense of a system. Latency is I am trying to, let's say, just retrieve information from a system. Like I'm trying to visit a website. The amount of time it takes for me from the moment I type into the Google search bar and hit enter, the time between then and then when the page loads. And you can say between that and when the first like part of the page loads or when the page finishes loading, but it's everything that is involved in there. And that comes down to how quickly your computer turns in like hitting enter to zeros and ones and then puts it on the wire going across the network and then retrieving the information and then getting the information back. There's a lot of steps involved in there. Yeah, that's pretty much how you would define latency in this sense.
Okay, thank you. And tests, so you say tests, so you need to continually create tests and make sure that your system is continually passing these tests.
Yeah.
So I've done a little bit of testing, and I've heard of unit tests and UI testing.
Yeah.
Is it unit testing?
No, not quite. So you can think of unit testing as the smallest form of testing, right? These are going to be very lightweight. They're really not designed to test anything large scale. They're just designed to test the smallest building blocks you can make and say, yes, this building block does what you think it does. And it fails when you expect it to fail. And that's really all a unit test does. What the larger tests that I'm kind of talking about here, there are different flavors of them, but they're load tests, things like integration tests. These tests are designed to test the overall product, right? If I gave you a black box and I said, if you give me, if I give you a black box and I say, if you feed in a number, this will feed you out the number +1, right? All it does is add 1 to a number. What you would do is you would, or actually, let me walk that back. Let me make the black box far more complex. You give it a number, it gives you a number, but it takes, it just does a bunch of stuff with it. But you don't know what's happening inside this black box. You can't really see into it. The idea here is that I don't care, and I don't care if changes are made to the box, within the box, anything about the box. I just care that every time I put in one number, I get the expected result coming out of it. So if you change this box, if you were to change the color of the box, turn the box upside down, my expectation is that it just works exactly the same. And that sort of stuff is called integration testing. And then there's load testing. Load testing is in, okay, the box was designed to get one number in and produce one number out. And it does it like that, super fast. Okay, well, what if I were to send in a bunch of numbers, one right after the other. And I just continuously, as soon as I sent one in, I was as fast as I could, I would send another one in. And as fast as I could, I would send another one in. And I did that, 9, 10 billion times, right? And the output, I would expect to see 9 or 10 billion results. And if I didn't, then I would know that somewhere in this black box, a number got lost, something failed. So that's something that I would be testing. The other thing is, if I send in that 9 billionth number, if it takes an hour for that 9 billionth number to come out, then there's a problem, because the first number, it came out just like that. And I shouldn't expect to see an hour-long latency or anything comparable to that. When I send in that last number, the idea is that the box should be able to handle that amount of data. And if the box isn't able to handle that amount of data, we'll then make 2 boxes and I'll split my input between them. And if still the boxes aren't able to handle them, then make 4 boxes and I'll throw in data to 4 of them and get 4 different outputs, or 4 outputs for all the numbers I'm putting in. And then you just continue to parallelize, or what we call scale, based on the size of the problem. And so these load tests are able to tell us just how much one box would be able to handle. And so in all this example, replace the word box with system, and you'll have your basic typical load bearing tests and your integration tests to make sure that the numbers are correct as they come out of that test. And these are fairly standard practices when large companies, at the company I work at, when we deliver our solution, one of the first things that they do is they load test it, and they just throw a high amount of data at the systems we build, and they just make sure, does your system break? Do I get the right answer? Or does all the input eventually generate output, or some input lost within the system?
Okay, I got it. And so that parallelizing of the system, do you first go through the load bearing test before you even determine how many different instances of your system you need?
Typically, yeah. So I mean, and that's the question, right? Because the more you parallelize, the more electricity you consume, the more the power company is going to charge you, right? So the more expensive it is to kind of operate and to parallelize. You're creating more instances of these black boxes, so to speak. And so you want to reduce the amount of black boxes, but you don't want to reduce it so much that it takes a long time or your black box starts to fail. So exactly, the purpose of kind of these load tests are to figure out exactly how much this box should be able to handle. Now, you can be intelligent about the design of your box, right? If you design your box poorly and it turns out it can only handle one number an hour, then that's your limit. But you can be smarter about how you design the box or how you construct the box so that it can handle the most amount of numbers. And on top of that, you can reasonably deduce how much throughput or how many numbers your box can handle before even having tested, either by experience or by you can judge the algorithmic complexity. You can judge how complex the box is or the software is, and you can judge how long it'll take if I send in 10 numbers versus 100,000 numbers. And based on those judgments, you can make reasonable assumptions as to, okay, I'm probably expecting I'll need this many boxes. And that way, in the wild, in production, you don't really have to guess, well, I don't know how much this box can really handle. So I'm going to, you can, with these judgments, you can assume I'll need 7 instances. And so you spin up or you instantiate 7 of these boxes, these systems, and you're able to then do your load tests. And if you're happy or unhappy, you either add a box or take away a box or whatever you want to do there.
Okay, got it. And so, do you know what order of magnitude or how many boxes there would be for different types of products? Say, like I'm assuming a product like Gmail has a large number of parallel systems.
On
Like,
their back end.
yes.
Yeah, I mean, no, and that's kind of, I mean, that's a little bit of the secret sauce of Google. I mean, if I were to try to reproduce Google or Gmail, I could build out the front end. I could build out the website to look exactly the way it looks, to an ordinary user because I have access to that. But then comes the algorithmic complexity of what's happening on the back end. And that's kind of the secret sauce, because even if I were to make a Gmail that looks prettier than the current Gmail, then if it was slower or it didn't scale or it was faulty or inconsistent, then Google would have the superior product because they would have that better backend. And so to a certain extent, they don't really want to share that amount of information. And to a larger effect, then that number of instantiations, the amount of parallelization, it fluctuates. You're able to identify how many instances do I need right now? How many boxes do I need right now? How many numbers am I receiving right now? And taking it a step further, you're able to, use a certain amount of machine learning, use some amount of data to predict or try to assume how much data is going to come in the next hour. So it will take me, 25 minutes to add, another 1,000 of these instances, and I expect to need 1,000 more in an hour from now. So in 35 minutes, I'm going to start the process of adding 1,000 more, and I'll be prepared for, that sort of scenario.
Oh, wow. That's I didn't there are a lot of applications for machine learning that we don't even realize yet.
Oh, yeah. I mean, a vast amount of the applications of machine learning are geared towards making things more efficient. They're designed to work behind the scenes and to aid people, developers, business owners in handling these sorts of problems, dealing with mass amounts of volume, for example, or volume of data, that is, without the person even needing to be the one to make those actions or to make the judgment that I need 1,000 more instances.
Okay, got it. So you believe that's the main purpose of machine learning, is to handle the large amount of data in the background and simplify choices for us humans, the end user?
Oh, that is a good question. That is a good question. I don't know if I believe that is the main purpose of machine learning. I don't know what the main purpose of machine learning is. I don't know if there is a main purpose of machine learning. I mean, okay, if you want to, zoom out a little bit from that picture, what we're asking here is machine learning designed to help humans? And to that, I would ask you, are machines designed to help humans? And the answer, I think, is yes. To a large part, Apple isn't making a machine to make our lives difficult. Like no one really writes software to make someone's life more difficult or to that people don't care about.
They can though.
You can. You definitely can. You definitely can. And we're scared of people who do. But I think in a large part, machine learning is used to compute on data that we as humans have a difficult time understanding. And I don't mean large amounts of data, because there are machines out there. Natural language processing, or NLP, is a good example of how sometimes in machine learning the purpose is not to compute a large amount of data and give us insights as to what that data holds, or to repeat that data. In a large sense, that kind of machine learning is aimed at understanding what human conversations are about, and being able to interact with humans in a very humanistic way. And so, in that sense, the machine's learning has a different purpose. It's not designed to, give me insights on what the stock market's going to do tomorrow. It's to understand what I'm saying and have a conversation with someone and tell me if you think that that person needs help, or if that person is happy or sad or angry or upset, and in a very humanistic way, understand that person and then distill their sentiments to me. And so there's both. And then in other ways, machines are used to drive cars and fly planes, and machine learning, that is. So I think that machine learning, while it consumes a lot of data, its purpose isn't always to act on the large amounts of data, or to provide insights to the data.
Okay, got it. So it can be thought of as kind of an art then too.
Oh yeah, I would definitely say so. Yeah.
What types of, what aspects of, I guess I did want to go to your education, but since we're already here, what aspects of machine learning do you believe can be, viewed as more of an art than just kind of science? And really, with technical thinking, a lot of times we see it as just one sort of route, and
right,
there's only one correct path. But in machine learning, it seems there are multiple paths, and you can, depending on what you want, you can do a lot of things there.
right. And I think that I would call machine learning, I'd call computer science in general art, more so than just than cold hard science or engineering. And I think the reason is, so I think I'll start with the perception of why software machine learning is not immediately thought of as art. And I'll say that the reason is that a lot of engineering, computer science, and machine learning, people are results oriented. They're looking at, did this achieve the goal? And if it did not achieve the goal, it is a failure. And if it did achieve the goal, the question is, I mean, sure, it was a success, but the question was, can you have succeeded better? Can you have succeeded more? And you're always going to look at the result. How did you do that? Or like, where did you end up getting? But what I really like about machine learning, and I think software in general, and I really didn't learn this until maybe until I started doing my research, really, until I started actually doing my research and writing my thesis, was that there is a beauty in the novelty and the amount of creativity you can have when trying to find a better solution, right? And the way I liken it to, and I say this because growing up, I was a musician. I played a bunch of instruments and I wrote my own songs and all sorts of stuff. And so I relate computer science and machine learning, at least during my research time, to the time when, as a middle schooler, as a high schooler, how I used to relieve my stress by playing the piano for an hour. Just put my headphones on. I had an electric keyboard and I would just be there for an hour. And really the goal here was to enjoy myself on the piano, really, and play this music into, or to like write a song. But really it was like the exploration I had and the freedom I had to kind of be creative during that process. That was the reason I did it. And I described that as an artistic feeling. I described that as art. What I produced was not the end result of now I'm relieved of some stress. It was like the thing I produced in the meantime. That is the art. And so I liken that to machine learning because I find that there's a very elegant way, and sometimes a little less than elegant way of getting to the right, or I shouldn't use the word right, an answer, and a suitable answer, a better answer. But the process of getting there requires you to be like, well, I know I'm supposed to do it this way. I know I'm supposed to use an algorithm that does it like this. Okay, well, let's just take a step back and think about what we're trying to do. And what if there's another way there? What if instead of this model architecture, we use this model architecture, but we change this up and we borrow from here and we take from there and we kind of put it together. And you're not doing this randomly. You're not just guessing in what you want to do. You're building, my research was in neural networks. So, you're not just building a random architecture in neural networks. You're taking from intelligent designs, but you're being a little creative and saying, okay, well, if I were to use this portion, let me take a look at the results. Let me take a look at where that gets us. And even if it doesn't immediately seem like it's taking us a step in the right direction, let me explore that area and let me try to find the next step in that direction. And if it leads nowhere, well, in the process, I got the opportunity to pick something apart and say, I want to pull this out and put that in there just because I feel like it'll do a better job, or just because the math says it'll do a better job. And, so the goal here is still to produce something better, but it's more looking along the lines of what did you do? What was your process in getting to that answer? And so that's why I would kind of consider it an art form, because it requires you to not just be like, oh, I was taught this in my book and this is the only way that the algorithm works, and so this is how I need to do it. When you're building these larger systems, you get to make decisions. Does this process happen here or here? Does this happen first or last? And you get to kind of compose this, like, this script, this system that does the job that you wanted it to do, but it has a lot of your design, a lot of your interest, a lot of your opinions baked into it, and it's yours. So you feel a sense of like, yeah, I created that. I came up with it. I created it. I got creative with it, and I think that's really in the most basic sense a form of artistic expression.
I think so too. And like you said, for during your schooling, you created some softwares that weren't scalable, weren't like going to be put into production, but those were your pieces of art. Those were like a famous artist, Leonardo da Vinci, probably has a lot of scrapbooks in his, or little drawings in his scrapbook, and those are your drawings in your scrapbook. Those whatever neural networks you created in school.
Yeah,
and,
definitely.
and one place I think it's really evident that software engineering, like for me at least, where I realize like software engineering is more of an art form than other engineering. And you went through this experience too. We both went to UCSD. We both were taking classes in the electrical and computer engineering department and the computer science and engineering department. And I don't know, I'd be curious as to hear your opinion, but my opinion is like they were night and day, those two departments. Like ECE was stuck, 2 decades behind, and it was pretty much just learn this is how it is. You just need to keep your face in the books. Like,
Mhm.
whereas CSC, it's like you have to be able to communicate with your peers, figure out this problem. There are many, your life's just going to be way easier if you talk to other people and figure stuff out. And there's a lot more leeway to create your own thing than, just checking out the voltage within a circuit.
Yeah, yeah. I would definitely agree with you there that like for electrical engineering, there's a little bit more of a there's a lot a bit more of a scientific feel, a scientific rigidity there that really isn't present in computer science. And computer science does allow for the expression of creativity in ways that aren't there in electrical engineering, at least not when you get down to the low level, entry level, even as you start to build up a little bit more. When you just focus on the science part of electrical engineering, it really is a little bit less expressive. And to be fair, in computer science, there are those aspects as well. When you're looking at an algorithm, about how to best traverse a graph or how to best reverse a string or something, it's cold. It's just a scientific fact. This is how you do it. Anything less than this is slow and is undesirable. But it's when you zoom out and you look at the application of computer science that you get a lot more of the expressive design, and it's most easily seen in website design. UI, UX, user experience, user interfaces. These are ways that literally are being designed to help humans interface with machines. Of course, they're going to be expressive. Of course, they're going to be, experimental and more artistic in form. And so I believe in electrical engineering, there is some sense of that expressiveness, being able to express what you want. But I think it's harder to find a creative or expressive aspect of the application of electrical engineering, at least not to the same degree that you find it in computer science. And so there is that distinction, but I do want to make the point of saying that, well, electrical engineering, I think if you just zoom out enough and you look at maybe the applications of it, you do find that, okay, you can be expressive in the way that you do things in much the same sense as when you're building a software system. The system can be built poorly and it can perform poorly, and that's not desirable. And so you want to find something that's going to suit and get the job done. In the same sense, that's there in electrical engineering. I just think it's harder to find that sort of that niche in there to really be able to be a creative in the electrical engineering aspect of it.
You're very correct. It is much harder because you have to get physical
Yeah.
materials, whereas you can just have a computer and create, incredible software.
Yeah, yeah, and I think what you mean by that is that, like, um, in electrical engineering, you kind of have to abide by the laws of physics. The laws of physics is not an expression of art, I think.
No.
And at a certain point, the electrical engineering, you can't get so much more creative there. These applications have to be a certain way because there are physical components that you have to deal with, physical laws that you can't break. Whereas in computer science, you're right, that there's a lot more malleability. Like if this was the way things are done, well, you can just decide not to do it that way and do it another way and see where that leads you.
Yes, no laws of physics in the world of bits.
Yeah, it's true.
What were some of the biggest differences between your undergrad experience and your experience in graduate school?
Ooh. Um, from an academic sense, I would say, and I've actually said this a lot. It struck me, I think, maybe the first day of grad school, was that the professors prefer if you call them by their first name in grad school. They get uncomfortable actually if you call them, doctor, or professor. And the reason is because there's this large sense of being colleagues or equalness at the graduate level. At least it feels like you're being treated as an equal from researcher to student of research, you know? And it's a lot more of a, hey, let's work on a problem together, and a lot less of, I have material to impart upon you, and so sit there, you know, as a student while I lecture and teach, you know? And especially at a UC school where class sizes are enormous,
Huge.
very large, you don't get professors who really connect with the students. And professors, surprised, maybe not surprised, didn't get their degree in teaching people. You know, they got their degree in doing a lot of research that requires a lot of alone time. And so they're not always the best educators, and they don't always care about educating their students. But at the graduate level, it almost felt like there was a peer-to-peer relationship. And so starting off with calling my professors by their first names, I got to know what they did outside of the lecture hall. I got to know how they decorated their office is the most basic, you know, way of knowing a professor is like, what's in your office? They have pictures of their family. They go on vacations on the weekends. You know, they have research interests. They have research disinterests. They are interested in talking to you about your life. You know, you're a contemporary. Now, in reality, I mean, UCSD has some very prestigious professors, and so it may feel difficult to feel like a contemporary to some of these, you know, these people are inventing and discovering things. But I thought that was like one of the largest differences. And you know what? It really boosts your confidence when you talk to a professor in that state of mind, and in that manner.
It boosts your confidence in what sense?
Well, it makes me feel like they respect the work that I do, that they respect the fact that I'm there, and that they believe in my ability to succeed in that environment. And I'll tell you this, and of course, keeping names out of the conversation, there was a professor I had in undergrad that you know, I went to. Well, okay, I was in his class, and we were going over some algorithms, and on the last day of class, he sent an email. Actually, right before the last day of class, he sent out an email. He says, last day of class, we're not going to go over any class material. We're just going to talk about the industry and research, and we're going to talk about what the future of you looks like. Do you want to go into grad school? Do you want to go into research? Do you want to go into the industry? Here are the things that you need to know. And it fit into the scope of this class because a lot of the industry cares about your ability to write and understand algorithms. And so this was an algorithms class, so he wanted to help gear us towards industry, which was a great idea. And so I went to that class. I was going to skip it. I was like, I'll just study for finals. I don't need to know about the industry. But I decided to go. And he basically lays out, here's how you get a job at Facebook. Here's how you get a job at Google. And I started to kind of look around. I'm getting kind of antsy. And I look at my partner who we had talked, my project partner who we had been doing projects all quarter long in this class. And I started to get this feeling. I was like, I can't do any of this. Like, I'm not prepared to get a job anywhere. These people are so much farther along than I am. They understand the class. Apparently this class was useful for, you know, the industry. And my mind just goes to this place of like, listen, you're not going to make it here. You can't handle this. So I go to that professor's office, his office hours, like the next day. And I basically sit down, I say, here's my resume. It has basically nothing on it. Here's my transcript. You're not going to like what you see. And here are my goals. And, you know, what am I like? I don't think I'm aligned here. Based on what you're saying, there's no way I'm going to get to where I want to go. He looks at my paper. He looks at my resume, my transcript. He looks and he goes, listen, I don't think you're going to have a good time here. And I was like, what do you mean? He goes, like, the way you're going right now, you're not going to get a job. I don't think you're going to succeed in this field because of your transcript and your resume. You don't seem to be making any progress there. And I remember thinking, I remember feeling so defeated, but it lit a fire under my ass after that conversation. And so I went back to him. And so during that conversation, I asked him to be my mentor. I was like, can you just like guide me through college, you know? And he said no. He was like, I'm not going to waste my time with the student. He just had no faith in me. He said no. And so I went back the next week and I asked him and he said no. And I told him, I'll be here every week until you say yes. And eventually he did. And we set up a plan to meet 3 times a quarter. And that was January. And by that, I think April or May, I had an internship. I had undergraduate research lined up. I had gotten, A's for like the first time, in classes that actually mattered to my career. And from there, after that, I became an intern at Uber. I started researching all over the place. I got like 3 jobs on campus. I really felt like that kind of just sprung me into action. And I felt really good, And so then I started applying to grad school, and I went into this professor and I was like, you know me better than anyone here. You know what I'm capable of doing. And when I asked him to write me a letter of recommendation, he said no.
Wow.
He was like, I don't write letters of recommendations to people who I don't believe did very well in school.
Wow.
And this is me coming off of all these internships, and I'm like, have all this confidence. I mean, my confidence was shot to hell after he had that conversation with me. And he still didn't write me a letter of recommendation. After all, I mean, I was like, you and I have worked closely together for 2.5 years. And while I've had to pry every ounce of wisdom I got from him out of his hands, he still saw me grow and succeed and get better, and he still didn't write me the letter of recommendation. Lo and behold, I got into grad school in front of his face.
Nice.
And I got into his grad school, and I used to see him around the building. And whereas before I would not really look at him in the eye, this is someone who didn't believe in me. This is someone who just constantly told me I couldn't do it. And even when I felt like I did do it, he still told me he didn't believe that I could do it. I would walk around, I just held my head a little bit higher, because
Nice.
here I was in the grad program of a school that he said I wouldn't even get a degree from. And I was amongst the best of them, and I was getting respect from all of his peers, from all of the other professors there. And so I feel like I had a lot more confidence in what I was doing, because you have that, the professors there speak to you with a certain amount of respect. And I can't imagine that if I was in grad school and I had gone to him and asked him to be my mentor, he would have ever spoken to me that way, And so I truly do not harbor any ill feelings toward this person, because it was because of this person that fire was lit. I mean, I was told I couldn't do something, and so of course I had to go do it. And now I went to grad school. I did research in an area that I think is badass. I got my dream job at a startup that I think is amazing. I'm getting opportunities to do things that I never would have thought that I'd be able to do this young. And I'm meeting incredible people. And it's thanks to the fact that I was reminded that what I want, is not just going to come, and that I'm not going to have, it's not going to necessitate me being there doesn't necessitate the respect of professors. You have to earn it. And I felt like being in grad school and being there as a grad student really earned me that respect. Now, I don't think any undergraduate should be spoken to the way that I was spoken to. I'm not saying that you need to be spoken to poorly in order to do well in life. I'm just saying that one of the biggest things that I really felt was that these professors were very respectful of me, and they respected the work I was doing and my presence there. And that was very meaningful to me.
That sounds very meaningful. And it's a huge deal, to be respected and to be looked at as a real human with value, not just like some burden on that guy's day for going into his office hours weekly.
Yeah, exactly. Or needing to, I mean, my meetings with him were 15 minutes long, 3 times a quarter. And still, every time I walked into the room, I felt like a burden. Every time I walked into the room, I felt like this guy, his life is not as great because I'm asking him to help me, as opposed to the alternative of being supportive for the same 15 minutes. It costs you nothing else. And so,
No.
I feel like in grad school, there was really, that was the sense of validation that I felt like I had to show it to him that I had done it, and that I went to his grad program and I, succeeded, despite the fact that he didn't want to recommend me to his own program.
Damn, that those things, I mean, those kind of like, especially the first one where you said that the last day of class you went and he showed you this is what you need to do to get a job at Facebook and you felt like you couldn't, that can be like a rock bottom moment. I've had my fair share of those and it's tough. It's a tough pill to swallow.
It is a tough pill to swallow, and it's exacerbated by the industry itself. The industry promotes the idea that an unhealthy obsession over the interview process is the way you get a job, and that spending incredible amounts of time just studying the questions that they might ask you is the way to get a job, and that your performance in that environment is indicative of your performance at the company. And I mean, it's a well understood problem that is not the case. You can't stress someone out and then give them a hard problem and expect them to solve it, and then expect that person be able to represent your company well. If that engineer is expected to talk to customers, you're gonna run into some problems, because those people are designed or training to pass these interview questions and pass these interview tests. And so, yeah, the feeling of imposter syndrome is rampant in the software industry. More so for minorities, more so for women, underrepresented communities. You start to feel like, I'm here because they felt bad for me. I'm here because I got lucky in the questions they asked me. And aligning yourself with that thought pattern, makes you feel not confident in your ability to perform in that capacity.
Oh wow. Is this a, I mean, so just going to my experience, then I'll ask you. I felt the same way. I mean, it's definitely a good type of systematic process where it's like if you want to be a software engineer, you have to study these algorithms. It's
Mm,
good to know, but like I remember this. It's just like you have to study these algorithms. You have to get this book that's like how to pass the software interview. Um,
and it's
and
cracking the coding interview.
cracking the coding interview. That's it. And you have to study that. And then once you get into the job, you pretty much just have to regurgitate whichever solution they give you. And
Yeah.
I it seemed to me later down the line, like a couple years, like just referencing back to that, I was like, that doesn't seem like that's not really how the day-to-day job works.
Yeah.
So is there an imposter syndrome? Is that an actual like
Oh yeah.
issue within Silicon Valley right now?
Oh yeah. Oh, within Silicon Valley and the greater research community at large. Oh yeah. I mean, imposter syndrome is everywhere, right? It's not purely computer science. It's not pure. It's anywhere where a a certain demographic is promoting themselves for in a style that makes others feel like they just don't belong there, or like they somehow got lucky to be there. It's usually the product of being otherized, and it can appear because you're the only person who looks like you in a room, or the only person from that background in a room. And so it makes you feel like, why am I the only kind of person like me in this room? So it's everywhere, and it's for every industry. But in computer science, um, in my opinion, in computer science, the barrier to entry is access to a computer. And while there's still a barrier there, it's significantly lowered as time goes on. And so the only remaining feeling of like going into that industry is the feeling that others are a better fit for that industry than you are. And so I can tell you, while I was in grad school, I took an interest in teaching. And for me, it was teaching the lowest level computer science class, specifically for students who were not in the computer science program. So these are students from other programs who want to dip one pinky toe into computer science. And the reason I took an interest in in that is because teaching that class often requires more involvement from the TA. So you don't get very many TAs wanting to teach that class. And the ones that do teach that class are not there by choice, and they don't do a good job. And they end up scaring students who might have otherwise enjoyed computer science, but because there was a lack of engagement or interest from the TA or from these instructors, they end up shying away from the industry. And I've seen that in undergrad happen to close friends of mine, where they would take one intro class and the TAs would be horrible and the class was designed terribly. And they
It
were
was
like,
designed to make them fail.
it was designed to
At
make them
time,
fail. And it gets framed in the sense of, well, we only want those who push themselves hard enough to learn, or want it enough to really succeed in the class. We want to, sift out all the people who are just here to explore, and we want those really hardcore, that whole sense of like, we only want the best kind of thing. It really suppresses those who can be the best that they can be. They just need a little bit more nurturing. And so I taught those classes because I wanted to do a good job, and I wanted to help those people. And so a topic that was widely discussed in those classes in particular was, how do we make these students feel not so intimidated by computer science? And admittedly, computer science is a different way of thinking. There is a learning curve, as with everything else. The learning curve is a little bit steep, but with the right nurturing, people get over that hump and they just skyrocket. And so, I worked with a professor whose research at the University of California, San Diego, was not a technical research area. They are actually researching, how can we better teach computer science to students, and not just students, to this demographic of students, that demographic of students. How do we better engage with them? Because if we want to see that diversity in the industry, there has to be that diversity in the education pool. And okay, I say education pool, but anyone who's like looking to get into software, because you can get into software by doing the boot camp or self-teaching, but you have to have diversity in the people who are learning computer science. And so how do we engage with those students starting all the way at high school? How do you get them into it and not scare them off? If you don't have parents who are very well literate with the, like technically literate, you're going to have a hard time asking for help. You're going to have a hard time acquiring a computer that can work, asking for debugging help, And so how do you get those people into it? So yeah, I would say that the imposter syndrome in software specifically is rampant, but I also think that it's highly, highly talked about. It's surfaced a lot, and we attack it by surfacing it and by saying, hey, listen, like, I don't feel like I'm as good as my contemporaries, and allow yourself to feel that vulnerability. And we attack it by saying, listen, everyone here is not great at something, and not great at something within computer science, and we're here to help teach you. And that's all it is.
computer science is very intimidating. If you're for me, as a quote unquote engineer, in college, it was still intimidating to get into. So I can't imagine for people who you don't even consider themselves technical, it's
Yeah,
got to be very daunting.
definitely.
And dang, I just lost what I was going to say.
Mm.
But being vulnerable is also, especially in the workplace, is not always easy, but it's imperative, because
Mm-hmm.
if you're able to admit to what you don't know, then especially working within a software industry, it's going to be like if you aren't to the capability of your colleagues, you should let them know immediately so that they can help you out and help you gain that skill set
Oh yeah.
as soon as possible.
Oh yeah. Yeah, and I'll tell you a story here that my company, it's named Instabase. It's based in San Francisco, and we in the last year we've grown from about 60-ish people. I think I was like the 60th hire or so, and we're now at about 150 40 or 150. And
Wow.
I just hit my 1 year 1 week ago. And during that time, the company has grown to a size where we can afford the time and money to incubate another smaller team that's designed to find the next step of our company. You know, like our company is an operating system. We design a platform and we have proven its utility in the document understanding space. But we want to prove its utility in a completely different space, completely different vertical, because we want to prove its utility. We also want to develop its utility amongst a breadth of different verticals. And so so I'm one of the engineers who's in this small incubator. There's 4 of us, 4 engineers here. And one of the things that we have said to each other constantly is that we don't know how to do what we are planning on doing. And we have gone out and we've gone on to find online courses. We have held what are called brown bags, just technical conversations with each other. Someone here has a tiny bit more experience with this technology than the rest of us. Let's just, you talk about what you know. And so then we'll all know the same thing, and then we'll all be able to grow from there. And there's a constant conversation. I would say, I say the phrase, I'll need to learn how to do that maybe like 5 or 6 times a day, because there are just that many things that I need to learn. And I have to be able to say, I don't know how to do that, but I'm gonna go learn it. And I'm gonna learn it at a rudimentary level. And then I try to apply it at an expert level. And what I'm gonna do is I'm gonna cause a lot of errors. I'm gonna make a lot of mistakes. I'm gonna fail a bunch of times, but I'm gonna do that every single day. And one of these days I'm gonna get it right. And one of these days you're gonna get it right. And so one of these days we're gonna get it right. And we're gonna move past this. And that's just a constant iterative cycle of expecting ourselves to fail, expecting it not to go the way we plan it to go, and inviting the failure as a reason to, or as an opportunity to pivot. And we don't have to pivot, but we should at least ask ourselves, did we take the wrong step, or did we not take the step correctly? You know? And so, yeah, being able to admit and say, hey, I don't know what I'm doing here is 100% a part of the job, and 100% a requirement for being in such a small team designed at going to figure out what's next here. What technologies do we want to build? What markets do we want to get into? You know, and so that's been a huge benefit, you know, a huge learning experience, that being able to say, I don't know how to do that, but I'm going to find out.
That, you know, that way of thinking, I don't know how to do that, but I'm going to find out. It's really simple. It's, you know, not very complicated way of thought, but going back to the interview process that a lot of software jobs have, that is the complete opposite of, you know, kind of the whole process. It's like, you know what you're doing, and
Yeah,
we're going to present you a problem, and you're going to know the problem, and you're going to get through it.
yeah,
And
exactly.
I can actually see that being, you know, more useful depending on your company size. Like for Google, it might be a little bit more useful to have software engineers that know a specific, you know, functionality, a specific capability within software. But for, you know, a company like Instabase that just added 80 to 90 employees and is looking to hit a new sector, I mean, it's going to need creativity, people
Mm-hmm.
who are willing to speak and, you know, try new things to be successful.
Yeah, yeah, it does. And I would say that, like, at least to the extent that I have influence over it, and I think my colleagues share this sentiment, is that the software interview process is not just about what you know, it's about showing examples, or it's about being willing to figure out how to get past what you don't know, or using what you know to as a strength while developing your weaknesses or what you don't know, and continuing to learn. And I think that's been highly valuable. The result is people who have who are skilled in their area of expertise, but are also humbled in their willingness to continue to learn and to admit that they don't know something. And so, yeah, I would definitely say that like the interview, I would say you're spot on there. The interview process as it is posed now, very much so emphasizes people who say who can know everything there is to know about an interview process. And the worst part is that the interview process isn't all that indicative of what the industry is actually like. So someone who knows the interview process very well may not know the ins and outs of building software, or even be a good software engineer in that very same sense.
Absolutely. The job is, it can grow like yours seems to be from, just this couple of taskings to, you figure out your next job.
Yeah. Yeah, and that for me has been a blessing. I mean, that's something, I mean, my goal at some point, I'm going to start my own company.
Nice.
And that's just, so everything I do is for the purpose of learning exactly how to do that. And one of the things that that really attracted me to my company right now is the need to talk to customers. In my role, I'm the main developer, software engineer, but I also speak a lot with the customer, and that tends to be the case at smaller companies. But my role specifically is one where, like, when I deliver my solution to the customer, I then have to walk them through the solution. I have to explain to them, and then I field questions. And so I learned that skill by joining Instabase. Well, now with this whole like very small, team iterative process of figure out what your next job is. I mean, that to me is exactly where I would like to be positioned right about now. Figuring out what does it mean to, like, we were essentially given a blank slate. We're essentially a startup within a startup, but a startup that doesn't have to worry about funding and has job security. So we don't have to worry about where our paycheck is coming from, and we don't have to worry about where the funding for the project is coming from, but we get to play around and figure out what problems are out there. We've had 20, 30, 40 interviews with other professionals out there. We were just like, hey, what's your problem? We just looking for a problem to solve. And once we have identified it, we'll go after it. And then if turns out we don't want to solve that problem, we'll turn around and we'll go interview more people, and we'll go find that. And that kind of process has been, a really big positive lately in where I see myself along the path to starting my own company. I mean, this is practice right here is what I'm doing. And I'm practicing with the best of them. So yeah, very, very excited about what this next chapter holds here.
That's awesome. And best of luck to starting your company.
Thank you.
Working in a small company environment is I personally think I work for a small company. I've worked for two. And like, if you worked I don't think at Uber or Google, you could speak to a customer, or you could, present a solution and then see their reaction in real time and then be able to work off their reaction. That's a huge, great piece of experience that you're receiving.
I definitely, and it's satisfying. I mean, I've had to hear a customer tell me this solves my problem. Is like the best experience, because you just took a skill, a passion, dare I say, that you have, and turned it into making someone's life better, easier, and in a very focused manner. You're not solving world hunger, but it helps someone with the thing that they do for a living, and it makes their life a little bit better. And so it's very satisfying to hear your customer be like, thanks, good job, I appreciate what you just did, more so than your boss patting you on the back and saying, good job. It means something when when a paying customer appreciates and enjoys what you had just produced for them.
It does mean something. That time you just put in is, to you, it's more than a paycheck. And
Yes,
they're, them recognizing the hard work and the quality of the product, it really gives you that, as you said, gives people that sense of feeling of value.
exactly. Yeah, yeah.
Do you know what type of company you want to create, or do you just know that you want to be an entrepreneur?
I know I want it to be enterprise software, software that I write and sell to other companies. But what that company does and who that company is, or who in that company I want to sell to, I'm not sure. I thought I knew. I thought I could find out. I thought I could just Google it and be like, what's your problem? And try to find what people wanted. But you know what? This whole incubator thing in Instabase, it's been a great eye opener. Realizing it, like finding the product and the product vision is just as hard as building it, and positioning it just right. But I'm learning from some truly, truly incredible people. And I'm really fortunate to like have those people to like I don't really know how to contribute to those kinds of conversations, but listening to them has been very insightful. So it will definitely help me when I'm trying to figure out exactly how to, or like what kind of problem I want to solve.
Absolutely. And you don't have to speak. I mean, sometimes it's better to not speak at all
Right.
and just leech off whatever information you can get, especially at our age. Like I do that a lot too, where it's just like I don't really speak in the meeting. I just listen and take in and, try and
Yeah.
grow.
Right. Yeah. And learn from these people for sure. For sure.
So going back to school, you said that you did some research and some stuff that you thought was pretty badass.
Yeah.
What was your research? And you also said you did undergrad research. So I'm curious as to, how you got involved with undergrad research, what it was, and also what your actual, for your master's, what that research was.
Sure, sure. So I'll tell you the story of how I got my undergraduate research, just because I find a lot of entertainment in how I got it. I think it's hilarious how I got the job. But it started because in undergraduate I was a tour guide. Right, I love talking to people. I loved walking backwards, so I was a tour guide. And during one of there's the admit day at most universities at UC San Diego. It's called Triton Day. And so at Triton Day, we certain professors will open up their labs and give tours to prospective students to say, here's the research that I do. So my job was to, take people from the center of the university and walk them to these labs. So end of the day comes around, the last tour to go off. It wasn't mine to take, but the person who was supposed to take it couldn't take it. And so they were looking for someone. Here I am hiding in the bush, not wanting it. They say you. And so I ended up taking them up and I ended up meeting this professor. And he opens up his door. And so, the admits all go in, they're listening to him talk. Now, I don't have to be in the room. Like, it's like I could just hang out outside. But I was like, all right, it's the last one of the day. I should show that I'm an interested, engaged student here. I should put on a good face for the school. So I go in there and I start listening to the professor speak. And he starts to describe, he goes, oh yeah, I employ lots of, undergrads, or like they're a large part of my lab here. And I thought he was just saying that because he was asked to say that. But then he goes, here are the things that, like, for example, I'm looking for right now in an undergraduate researcher. And he starts going down the list, has to build a program, has to understand that, has to know this, has to have an interest here. And I'm like, I can do that. I can do that. Oh, I like that. I'm pretty good at that. And I was like, I should apply for this job. Now keep in mind that this was happening right after the other professor told me I wasn't going to make it. So I'm like, I could do this. I had that fire under my ass. I was like, I could do this. So I got that guy's, the professor's contact information, and afterwards I emailed him. I said, "Hey, I was that tour guide, but you were saying you were looking for someone like this. Is that like, are you still looking for someone? Because I could do it." And he goes, "Why don't you come into the office?" And so we talked, and I sent over my resume and everything. And he goes, "All right, why don't you come on board?" And just like that, I told him, like, I'll do it for free. I'll just volunteer. I had gotten advice from a friend who was saying, just volunteer. Don't even ask for money, because what professor is going to say no to free work? And so I volunteered for the first, I think, year. It was all free. And then he was, and it was a blast. I learned a bunch of stuff. I met a lot of really cool people, and the research was all physics-based research. It was all this professor, his name is Dr. Frank Werthwein, and he is a professor at the UCSD physics department, but he is an associate, or he has some sort of relationship with the computer science department. And the reason is that he works for the Large Hadron Collider. He uses the Large Hadron Collider over in Switzerland, I believe, to conduct his experiments. And from these experiments, large amounts of data is yielded. And so that's where we come in. The research topic was, how can we better that kind of scientific data, how can we store that data in a way that makes inspecting the data and doing experiments on the data and learning from the data fast and easy and effortless? Like, what kind of system can we build to make that specific type of physics experiment really easy to compute and to do? And so that was kind of the research area. And this professor, Dr. Werthwein, became a friend. He wrote me a letter of recommendation. He introduced me to people. He gave me projects that would help prime me for graduate school. He was a great mentor. And in graduate school, I was like, hey, like, the school, I couldn't get a TA position, which means that the school couldn't pay for my education. And I was there for the summer because I was doing research, but it was unpaid research. And so I was like, I need a job. And he goes, come on over, like, I'll find something for you. And he found something for me. It was part-time, didn't pay a lot, but it kept the lights on, so to speak. And so that was the research I did in undergrad. And that's how I got, into that, was just because I was like, all right, I'll take these admits to this lab. And then once I was there, I was like, okay, I guess I'll pretend like I'm a good student here. And it turned out like really, really well. So super lucky on that one. But it reminded me, you got like, these biggest packages come in the smallest, or the biggest gifts come in the smallest packages, right? Like, it was so unseeming that from this tour guide position, I was going to meet this person who would help me throughout the length of my time at UCSD in general. And so, yeah, that's the story of my undergraduate research. And then in my graduate school, I did research on neural networks, and I was actually in two different labs. So one of the labs, the first lab I got into, I still think does just unbelievable research. And the reason is because the professor of the lab, the lead of the lab, wasn't in the computer science department. He was in the music department. And his lab was researching, how can we teach machines to understand music? Imagine a world where you can teach a machine, you can show a machine Mozart, and the machine can learn, how does Mozart express himself in his music? Can you understand Mozart? And then you give the machine the notes to a Kendrick Lamar song and say, play this Kendrick song the way Mozart would have played it. And then just see what happens. And the machine comes out with this amazing thing. So that's kind of the thesis of a lot of the research there. And I just thought it was absolutely amazing. I was like, this is mixing my childhood passion of music. I mean, when I was a kid, I wanted to be a musician as a profession. And I didn't change my mind until high school. My friend was like, hey, you want to do this computer science stuff? And I was like, that seems pretty cool. And so it mixed this like passion of mine in my life and with machine learning and computer science. And I was like, this is the best marriage of the two passions. And then again, I asked the professor, will you be my mentor here? Can I be in your lab? And he said no. And the reason he said no is he's like, we don't take master's students. We only take PhD students. And of course, me being me, I mean, the other guy in undergrad, said no as well. And I, got him to be, I got him to be my like mentor. So I was like, I could do it again here. And so eventually he lets me in. And in about, I think it took me 6 weeks, I was like, yeah, this isn't the place for me. And the reason is, as cool as that research is, it is so complex. The topic is so niche. You have to spend 2 to 3 years researching the space in general before you even get to the problem space that they're attacking. Every single one of their students in that lab was a PhD, and they have been PhDs for 6 or 7 years because they spent the first 3 years just digging to the point. And that's when I realized, I was like, oh, the research is just intense. It's just really intense. And unfortunately, I don't want to spend the next 9 years of my life, at that time 9 years, in a PhD program. As cool as it is, like, I'm done with school. Like, I'm ready to be done in the next year. I had and I debated that for a long time. He invited me to stay on as a PhD. He goes, if you want to convert to a PhD, I will be, your mentor. I will be your professor there. But I couldn't commit to it at the time. And so actually, just in that time frame, another PhD in another lab reached out to me. He goes, I heard about like your research interests and what you want to do. Let's talk. And so I meet with this guy, and he basically says, listen, the professor you're with right now, he's not going to help you. You're going to do research that's not going to make sense to you. You're going to write a thesis that he's going to help you write, and then you're going to get out of there. It's not going to work out that well. And I didn't hear it well the first time. I was kind of put off by the fact that he was like, you're not going to, I felt very like told like, oh, you're not going to be able to do well here. But he said, just think about it. Take a week, think about where your future lies here. And I thought about it. And I was like, yeah, okay. Like, I was really excited about this research topic, but I just got to understand that this isn't the only time that both my passions in life will kind of come together. I got to let this one pass, and I got to move on to another research area. And so I did, and I thoroughly enjoyed it. And that research area was still in the deep learning neural networks, but it was in a little bit more of a nuanced area. And it has to do with what's called modeling a system, or it's called system discovery with repeatable, unactionable data. So essentially what that means, I can just speak in more tangible terms. We were researching how to build a neural network that can model the environment of a building based off of only temperature readings and the activity of the air conditioning system. So the idea here is that, let's say that you want to optimize your air conditioning system, right? A large building like the computer science building at anywhere, 48% of its power consumption was consumed by its air conditioning system, or HVAC system, heating, ventilating, and air conditioning system. 48% of its energy was consumed by the system. That is highly inefficient, right? If half of your energy consumption is coming from turning the air conditioning on, there's gotta be a better way. So the research was aimed at, can we teach the air conditioning system to be more efficient? Can we teach the air conditioning system the temperature needs to be at this temperature at this time? And so based on the outside temperature, you turn on when you think you should turn on. The current way of doing things is turn on at 6 a.m., turn off at 6 p.m. on weekdays, and weekends never turn on. But there's got to be a better way. There's got to be, maybe we can do something like what that system doesn't do is it doesn't leverage the fact that it's cold at night. Maybe in order to keep the building cool, we open the windows from 5:37 to 5:52 a.m. and the building cools down a little bit. And then we close the windows and we just circulate the air with a minimal amount of air conditioning. We've drastically lowered the cost of air conditioning, and yet we've been able to achieve the same result. So let's teach the air conditioning system how to do that. And so there's a few more levels and it gets a little bit more nuanced there, but that was kind of the basic thesis of what we were trying to do. And it turns out it's a difficult problem because if the model has never seen what happens if it's 100 degrees outside, it can't predict what happens if it's 100 degrees outside. When you train a model, you have to show it, oh, look, when it was 80 degrees at 2 p.m., and then it was 70 degrees at 6 p.m., this is what the temperature inside did. And the machine now knows, okay, when the temperature drops like this, the temperature in the room drops like this. Well, if I were to then ask the model what happens if the temperature is 100 degrees outside, the model's just going to guess. It's going to say, okay, well, at 80 degrees, it was here. So at 100 degrees, it's there. And so the idea is to create a model so that that kind of guesswork for the extrapolation, the inference there is highly accurate. And so that's where my research was. And then that problem generalizes to not just HVAC systems in the computer science department, but overall weather systems, and then not even weather stuff. It can, it can start to learn things that happen repeatedly, like traffic, right? If you train a model to learn the traffic patterns of San Diego on a given day, and then say what happens if Beyonce plays a concert, what is the traffic going to do? It should be able to extrapolate and learn learn the essence of traffic and then tell you what happens if Beyonce plays in San Diego.
Do Google Maps play on those algorithms?
No. That kind of identification happens by, well, okay, that's a good question. So I don't believe Google Maps traffic handles that. It's probably looking more at historical data. It says on a Friday at 2 p.m., this is what the traffic tends to look like. So there you go. But companies like Uber and Lyft and other companies who value knowing whether or not there's traffic, or whether or not after the Beyonce concert, a bunch of people are going to be calling Uber rides. Those people care about doing those sorts of predictions, and so they put a lot of effort into that. And in fact, that was one of the teams I was on during one of my internships, was the Uber trying to anticipate the need, a suddenly high need for Ubers, so that one, all the Ubers in the area weren't depleted, and two, the prices didn't just skyrocket, but instead they could tell drivers, hey, you should go towards this area because there's about to be, concerts about to let out, or we expect there to be high traffic, or they can start to direct drivers towards that area so that there's like people in that one area aren't just starved of Uber rides.
Okay, that makes sense. And
yeah.
A quick question: do you think that the model would be stored on the client side, and then the data that the model is kind of predicting its next iteration from would be stored in the cloud, and then it would be drawing off that to create its prediction? Or how do you envision like a standalone application with its own machine learning model inside?
You could put the model on a device, but the hard, and I say that because it's technically feasible, it's possible, but likely that's not what's going to happen unless the model is small and doesn't require a GPU, for example. Things you would be concerned about by putting a model on a device are things like battery power of the device, computing power of the device, and the amount of space the model takes up on a device. So believe it or not, a lot of these neural networks are sometimes like gigabytes in size, And
Yes.
I mean, it's because they have just stupid amounts of information in them. The models are very dense models. Put that on a phone, storage alone, it takes up a few gigabytes, right? Okay, but phones have a lot of gigabytes on them. So maybe that's not that big of a deal. Well, now it's because there's so many gigabytes, you have to bring the model into memory and you have to run it. So it's going to take up a lot of RAM. Doing that is going to take up a lot of battery power. The phone's going to get warm. Users are going to complain. It's just not going to be a good experience. It's not going to feel lightweight. If it's on the cloud, however, then you don't have to worry about how much power it takes or how much storage it takes, because you feel like you have unlimited amounts of both. But the trade-off is that when the user wants to do the thing that requires the model, a network call has to be made to the server executes, gives you a prediction, and then it has to come back. And the network call has long latency. Network call is slow, so it's not as fast. And so, for example, like Siri is, I believe most of Siri's voice recognition functionality is local. It happens on the phone. You could put the phone on airplane mode and still talk to Siri. The fact that you're talking to Siri is evidence of a model that is on board on the phone itself that does not need an internet connection. You're in airplane mode. But then if you were to ask Siri, what's the weather tomorrow? Siri will understand what you're trying to say. The model that learns and understands what you're trying to say is on board, but then it can't get the weather. So then that's going to fail, right? But the fact that Siri understood what you were trying to say, in other words, the fact that Siri converted your sound waves into words and then read the words and said, oh, Naveen is looking for the weather, and then attempted to go get the weather and failed because your phone is in airplane mode, that is evidence of a model being on board. So there are models that are on board the phone, but they're gonna have to be smaller and lighter weight if unless phones are able to kind of hold that kind of capacity.
And for Siri, that's a lot easier to do because it's Apple's hardware. They're able to integrate that software pretty seamlessly.
Yeah, I'm sure a lot of that has to do with the fact that Apple made the hardware, Apple made software, and that's what they kind of designed to do, design them to kind of work together. It's also because Siri is relatively lightweight, right? They were able to make the model not an entire gigabyte large, or if it is, there's only one Siri on your phone, right? Whereas like if Uber tried to put a model on your phone, it might try to put multiple models on your phone, or other apps would also be putting models on your phone. I mean, imagine you have Uber downloaded and it's taking up 5 gigabytes of your phone, or if, and then you have 10, 15, 20 of those apps and now you have no storage on your phone, right? So that would kind of present a problem.
Okay, that makes sense.
Yeah.
Well, going back to, your undergrad research, it's tough. I had an unpaid internship too, and it's pretty tough sometimes to do work for someone and then not get paid. It sounds like that professor was a pretty good professor, like helped you out a lot and
Yeah.
kept you going. But it also sounds like that job was necessary for you to get into, graduate school. Do you think so?
Yeah, I would definitely say so. And to be fair, so I was doing that research at that time. For that first year, it was unpaid. At the same time, I had a few jobs on campus and like one off campus, and I was doing that to pay my way through school. And at a certain point, he wanted me to commit to coming in a little bit more and doing more work. And I was like, I can't because I have work. So he was like, pick your like least favorite 2, and then I'll just start paying you. So he's like, quit from the least favorite 2 of your, had like 3 or 4 jobs at the time. He said, quit from your least favorite 2, and then I'll just start paying you. And he did. And he goes, this is the most I can pay you as an undergrad right now. And he was happy to do it. And then there was a portion where I had a quarter of my 5th year, at the end of my 5th year, where I wasn't doing any school. I was just living in the area. It was a great time, thoroughly enjoyed it. I was living in PB at the time, had my own studio out there. I was really enjoying life. And he was like, I can't, because you're no longer a student, I can't pay you what as a student researcher. But he was like, if you don't mind, I'll just hire you as like a human, as a person. And you just continue to do the same things, but I'll just hire you. And I was like, yes, like, of course. And he was able to pay me more. He goes, this is the max I can pay you. And that was it. And it wasn't like he didn't want to pay me more. The school wouldn't allow him to pay me anymore. And so I told him I didn't want to be hired full time. He was like, why don't I just pay you for 40 hours a week, and you tell me, or why don't you just tell me how much you work every week, and that's how much I'll pay you for. And then the other alternative he posed was, why don't I just pay you for 40 hours and then you just work 40 hours? And if you don't work 40 hours, tell me and I'll like adjust the payment. And I was like, I would rather just tell you what I work for, because I didn't want to be held to 40 hours a week. I was trying to live my life, enjoy my time a little bit. And I also didn't want to just take money from his department, and just be like, oh yeah, I worked 40 hours knowing full well I worked, a tenth of that or something, while I was out there living. But yeah, so it definitely was necessary. I don't know how I would have fared if I didn't have him. I don't know if I wouldn't have gone into grad school. I think I would have had a harder time, and I think I don't know what I would have spent my time doing, because I did have other things I was doing at the time. It's not like I was just riding on his coattails and was able to kind of get in the door because he opened it for me. He definitely introduced me to a lot of people, and he was specifically, he knew my research interest was in machine learning. So he gave me machine learning focused, oriented projects so that I could talk about them on my resume and in my grad school applications. And so he introduced me to a lot of people through that. And so, yeah, I would say that it was definitely because of that like I really gained an appreciation for that kind of research and that kind of work, but also that I was able to get to grad school in I mean, he was definitely like very, very impactful on my abilities there.
That's huge. And that's awesome. He eventually paid you. After working for free, getting paid for something technical is so rewarding.
Oh yeah. Oh
Even if
yeah.
it's like something like $10 an hour, at least you're like, I'm here making money.
This is my job, like,
Yes.
yeah, definitely. And you know what? He gave me an office. I'm pretty
Nice.
sure it was a storage closet. Actually, I'm sure it was a storage closet. There were things that were being stored in there, but it was my office. I carried the key. I had a stereo system set up in there. It's where I would study, and it had like 4 desks. So I would bring my friends to come study there because it was always available. It was my office. We had 4 desks, 4 chairs, 2 whiteboards, a speaker system in there, and I could close the door. It was a heavy door, so it was relatively soundproof. And so when the libraries were filled during finals, I mean, it was a great gig. Like I really appreciated everything that he had done for me. I mean, I was really, really blessed to kind of have him on my team, so to speak.
That's awesome to hear. And, something that I'm sure more people could take advantage of if they tried in undergrad.
Yeah, if they getting that research there is difficult. Getting to know your professors is difficult because they seem largely unapproachable. They may not be good at teaching. They have to make an effort to also want to reach out to the undergrads, and a lot of it has that respect factor as well. But I do think that like I grew in my character to having made that effort of going out there and trying to get this lab position and then getting it and then asking for him to pay me, and then eventually, working. And I was working with not just him. I mean, he had me go to meetings and help make decisions for people at other universities, who are all part of it because it's researchers work together at different universities. So I was sitting on those meetings, and then I myself would have projects without my professor, but it was just me and those other researchers. And so I got to like meet a lot of people and learn a lot of things.
Yeah, we got to take advantage of, pretty much I mean, all opportunities that seem pretty novel,
Yeah.
might be worth considering, especially in school, with professors and within labs and
Yeah.
education departments.
Right. And even I would say into the professional world. I mean, I would say it's harder because you're not just wandering around campus looking for free work, but like those same kind of, big opportunities and small packages. I mean, they're out there, and you just have to respond to the LinkedIn connection request, or you just have to email someone, or you just have to, pay attention to the ad or something. I don't know. There's lots of little things out there where like the biggest surprises often comes from the most unsuspecting of places. And maybe that's why there's such big surprises, because you weren't expecting it. You weren't expecting it to come from that area.
You haven't been looking there. You've been looking somewhere else, and that
Yeah.
place hasn't given you anything.
Anything. Right. Right.
So, Naveen, this has been a great conversation.
Yeah.
Is there any last things you'd like to say to everyone, or just about what we've been speaking about today?
I always speak to that imposter syndrome stuff. I consider it a significant event in my life when I consider the time in my life when my professor said, you're not really gonna make it, to be a significant influence on my career, because he was telling me the truth, and he was right. If I had continued to do that, I really wasn't going to make it. I wasn't really going to do anything. And so, that instilled in me a lot of imposter syndrome, a lot of a feeling of like, okay, I'm not really supposed to be here. I have a professor who's constantly telling me so. But I decided to use that as an opportunity to prove to only that professor that I was going to do it, and call that an obsession, call that unhealthy, but it had driven me to kind of show him what I could do. And in the process, I showed myself what I could do. I was really, looking back, I'm very proud of myself for the way I had done things. And so I guess my message, I guess my message here is that the imposter syndrome is a motivating factor. You can decide whether or not that mental block, it's just a mental block, can prevent you from moving forward and succeeding, or you can use it as a fire under your ass and get you to where you want to go. And you always hold on to that feeling of showing the world and yourself like what you're able to do. And so I think that would really be my message out there, is that if you want to do it, if you want to do it, go do it. Go show us you can.
My guest today has been Naveen Kashyap. Thanks for being on the podcast, Naveen.
Of course, it was a pleasure. Thank you for having me.